All right, so this is again a different type of numericals, questions, which you will definitely get in board exam, and these are teacher loving questions. So where you have to find the sum, they can ask you to find out the nth term, but important is that this is a multiple of a number. So basically, that number becomes your common difference, and when you have to consider the number that is lying between 300 and 700, specifically, they have mentioned over here. So 300 and 700 you will not take into consideration, and we always take integers into account because 7, it should be a multiple of 7 rather, and the common difference is 7. So to get the first term, what we need to do is you have to consider the term that is 301. All right. So 301, because I can't consider 300, I'll take the next uh, integer 301 and divided by 7. Why 7? Because it needs to be a multiple of 7, basically a factor of 7. So when I try to do this, this is nothing but 7 4s are 28, 7 3s are 21. So this number is definitely divisible. And is 301 lying between 300 and 700? Absolutely. So my first term, that is A, will be 7, which is the common difference, into the integer value which is taken into consideration. That is nothing but A is equal to 301. So that's my first number because we got an integer. If we hadn't got an integer, let's say we consider our last term. So when I don't get an integer, now in the last term, will you consider 700? Definitely not. You won't consider the term which is nothing but the 700, the value 700, because the number should lie between 300 and 700. So I will take 699 into account and then divided by 7. Now you might be thinking, so 700 is also divisible by 7. So, but this number, the number should, all the multiples of 7 should lie between 300 and 700. As I told you, the number should be between them, and you cannot include the number that is 300 and 700. So when I try to do this, this turns out to be 99 point something, 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 right? So how do I get my last term? So my last term, which is denoted by L, let's say, is nothing but 7 into if 99. I'll take the integer itself. So when I do 7 into 99, okay, so my last term will be 7 nines are 63. Yeah, 63 plus 3, 697. Correct? Sorry, 693, 97 covered. 690. Wait, let me just box it. 693. So 7 nines are 63 and 7 nines are 63 plus 6, which is nothing but 69. So these are your first term and the last term. Now, how do I get the series? So series basically will be, if I have to write the series in case, sometimes they do ask. So series is 301, the basically 301, then add plus 7 to it because you know the common difference is 7. That is nothing but 308, goes on all the way, and final number is nothing but 693, which you got. Do not consider 700. Okay, so this is your AP basically. So in this AP, you know what is your first term, which is 301. You know your common difference, which is nothing but 7. Yeah. What are they asking you? They're asking you to find out the sum of all the multiples. But before finding out the sum of all the multiples, what is the sum of all the numbers? It is S of n is equal to n by 2 into your first term plus the last term you can do. All right. First term plus last term. Also, you can use the same formula, which is not the other formula, that is Sn is equal to n by 2 whole bracket 2a plus n minus 1 into b. So in both the cases, what's important is you have a, you have b. Do you have n value? You don't have n value. So you need to find out n value. What is n value? The nth term, the last value, this, which 693 is a value, but what is the position of that number, or how many numbers are there in this series, basically. So I have to find T of nth term. So T of nth term, that is nothing but my last term, is equal to A plus n minus 1 into B. So last term is 693, where A is nothing but 301 plus n minus 1 into D. Now D is nothing but 7. So when you try to do this, it's 693 minus 301, which is 392. This 392 is divided by 7 to get n minus 1. So n from here turns out to be 57th term, correct? So 57. N from here turns out to be 57. So there are basically 57 terms between these 300 and 693. Now you might be thinking, sir, why did I have to find this? I could have used this. Sir, even though you use the first formula, you still need to find the value of n. You can use either of the formula, but okay, I'm using the first formula, S of n, which is nothing but n by 2, that is 57 by 2. First term is 301 plus last term is 693. So when you get this S of n from here directly, so you have 301 plus 693, that turns out to be 994. So S of n from here is nothing but 57 into 994. That is, it's quite huge number. 28,329. So you have to do the calculation. I'm doing it directly in a calculator. Okay. I just have to put across how to do the things, I hope. Yeah. So it is 994 divided by 2, which you get 497. Multiply that into 7. You get 28,329. That is nothing but the sum of all the multiples that are between 300 and 700. So I've written the series also, which is definitely required most of the times. They can ask you T of, now that you have 57 terms. They can ask you what is T15. So T15, that is nothing but the 15th term. You'll have to find it out. Like here, the 57th term is 693. First term is 301. Second term is 308. Right? So same thing. So this type of question where you have to find the sum of all the multiples of 7, and it is lying between 300 and 700. That is important. That do not consider 300 and 700 as a multiple, even though they are, because you have to find the numbers that are in between them. Okay. The second type of questions, okay, again on the similar lines, you have to find all the 3-digit numbers that are divisible by both 2 and 5. Now you look into this. Again, you require 3-digit numbers. Okay. And it should be divisible by both. Important is that it should be divisible by both 2 as well as 5. The word is and. That means it should take the intersection. So first, let's find out divisibility by 2. Okay. Numbers divisible by 2. So when I take the numbers that are divisible by 2, which number should I take? Definitely it's a 3-digit number. So 3-digit numbers starts from 100. So let's consider the first term. So now you might be thinking, so can't I consider 101? Why did I consider 100? So they didn't mention that you have to find out the numbers between this and that. Here they just told it should be a 3-digit number. Could be anything. So first term, the first 3-digit number is 100 divided by 2, which is nothing but 50. It is an integer value. So you got your first term directly. So A is nothing but 2 into 50, which is basically 100 itself. That's your first term. Similarly, you have to find out your last term. So last term of 3-digit number is 999 divided by 2. 2 4s are 8, 9, that is 19. 2 9s are 18, 19. 2 9s are 18, point something, something, something. Right? So to find out the last number, it is nothing but You have to take the integer, that is the preceding integer, because this is 499 point something something, into the multiple itself. So it is nothing but when you do 499 into 2, you get 9. 499 into 2, you get 998. So you have your first and your last term. Correct? We'll just speak about the series a little later. So if you see, okay, so very good. So if you have to see the series in this, which are divisible by 2, the numbers are 100. So what should be the common difference? Sir, it is divisible by 2, so it is 2. 102 goes on, you can write 2 numbers enough. And the final last number is 998. Okay, now let's consider the numbers that are divisible by numbers divisible by 5. So when I have to find the numbers that are divisible by 5, again I have to consider my first term, which is nothing but 100 divided by 5. 2s are 10, 20. So your first term basically is 5 into 20 is nothing but 100 is the number. And your last term do not consider 1000 because 1000 is a 4-digit number. You should consider 999 by 5. 5 ones are 5, 4 5 nines are 45. Correct? 999 divided by 5. 4 5 nines are 45. 45 49 5. 199 point something something something. So last number. The last number is 199 into 5. So last number will be nothing but 995. Correct? So the series in this will be nothing but you have your series. The first number is 100. Second number will be 105 because it's a multiple of 5. Goes on all the way to the last number, which is 995. It's nothing but 990. Okay. So in this, since there is and into consideration, what is that? There is and into consideration because and means you have to do the intersection. You have to take the intersection. So when and is there, you have to take all the intersection values. Now, if you see the intersection values, 102, 10, definitely 1010 is also divisible by 2 because 1010, sorry, 1010, 110 is also divisible by 10, sorry, 2 as well as 5. So when I consider the intersecting numbers between the two series, consider all the numbers that are divisible by both 2 and 5, or 2 as well as 5. So the numbers are, so that time the series will be 100. 105 is not divisible by 2. Do not consider. So next number is 110. Is 110 divisible by 2? Yes. Next, 115 is not. 120 is. So it goes on like this all the way till 995 is not. So it should be, last number will be 990. Correct? It should be 990, which are both intersecting to this. So if you look into this now, the first number is 100. The common difference is 10, and the last number is 990. What do I need to find? I need to find how many numbers are there. Basically, the last term, what is the value of n? I need to figure that out. So Tn I need to find, sorry, n value. So Tn I know that it is nothing but 990, which is nothing but a plus, given by the formula, a plus n minus 1 into t. So where Tn is 990, a value is 100, n value is something that I need to calculate, d value is 10. So this becomes 880 divided by 10 is equal to n minus 1. So this turns out to be n is equal to 89. So 89 terms are there, 89 terms. If you want, you can just write down 89 terms. There are 89 terms which are there in the 3-digit numbers and divisible by both 2 as well as 5. So you need to take the intersecting numbers. Okay, and means intersection. Here they can also ask you to find out the and implies intersection. Here they can also ask you to find out the sum of all the terms that are divisible by this. So now that you know the series, don't you think you can find out the sum? It is simple. Just like in a previous formula, you can just use a formula, and just like a previous sum, use the formula, get the answer. Because you know n value, you know a value, you know l value, you know the common differences. It's fine. So you can do anything. But only the thing is that you need to understand that and means intersection. Similarly, if I give you or related question, so if the next question which you can have is an or question again, but here I've given you 2-digit numbers which are divisible. Okay, first important thing is that these are 2-digit numbers and it is divisible by 3 or 6. So when I have or into consideration, or means by both, so it's a union. Okay, sets related thing, intersection, union, if you remember, the same thing. So let's consider the first term. Okay, so numbers divisible by number divisible by 3. So when I have the numbers divisible by 3, my first term, which is the first 2-digit number, it is 10. 10 by 3 is nothing but 3 3s are 9, 3 point something something something. So I need to go to the next term. So my first term a is equal to 4 into 3. So a is nothing but 12. So first 2-digit number that is divisible by 3 is 12. Then I need to find out my last term, but it should be in 2-digit number. So I'll have to consider 99. This last 2-digit number divided by 3, which is definitely divisible. So my last number is nothing but 3 into 99. Sorry, 3 into 33, which is nothing but 99. Okay, all the questions where you have to do, if you have understood that throughout, we'll be doing only one thing, that is nothing but finding out the first term and the last terms. So here, numbers which are divisible by 6. So when I have the numbers divisible by 6, so my first term is again the same, 10 by 3, sorry, 10 by 6. It's nothing but 1 point something something something. So a is equal to, I have to consider the second integer, that is 2 into 6. A is nothing but 12. So 12 is the first digit. Sorry, not first digit, first term. And then I have my last term into consideration. I'll have to take 99 into consideration, divide by 6. It is 6 ones are 6. 3, 6, 6 are 36, 16.66. So will I take 16, 17? No, I'll have to consider the last term as 6 into 16, 36, okay, 96. Now you know your first term, you know your last term. So if you have to find out the series, you have to find out the series. So series is nothing but here in this scenario it is 12 and then plus 3. Why? Because it's divisible by 3. 15, 18 goes all the way till 99. Just a minute, I'm just getting a call. So the series is this. Now when I have my next into consideration, the series for this, so this is nothing but 12 plus 18, correct? 24 goes all the way till 96. Goes all the way till 96. Just a minute here. So now, since it is OR, okay, it is nothing but union. So what we'll have to do, we'll have to consider, so we'll have to consider both, which are divisible by both 3 and, so consider all the numbers that are divisible either by 3 or 6. So the series that time will be 12. So definitely all the numbers that are divisible are nothing but multiples of 3 only. Because 18 also comes here, 24 is also divisible. All the numbers are there. So 12, 15, 18 goes all the way. You should don't consider 2 times, okay? 96. So here you know what's the first term, that's 12. Sorry, not 96, 99. Okay. What's a common difference? B is nothing but 3. Last term is 99. Yeah. So I have to find out again n. So T of n is nothing but a plus, given by the formula, a plus n minus 1 into d. So T of n is 99, where your first term is 12 plus n is unknown and the common difference is 3. Correct? So now when I try to do this, this is 7 and 87 by 3 is equal to n minus 1. Enough place, so I'll just continue over here. So or I can write it directly. So I'll directly write the value of n. So n value from here is 3 2s are 6, 9, 29 plus 1 is 30. N value is nothing but 30. 37 by 3. N value is nothing but 30. So these many terms are there, two-digit numbers are there, which are divisible by both 3. It could be divisible by both 3 or 6. Anything is possible. Okay. So now if they ask you the sum of n terms, I think it is possible for you. So they can ask you any such question. So this is again a type of questions which pops in. Yeah, you can just do this.